Hey and welcome back to the lab. And today here on the bench we have another Yaesu FT-857 which finally has given smoke signs during transmission until it finished completely. So that is very interesting. Let's have a look inside and let's see what we can do. Okay, and here we have our poor radio right on the bench, and so I've been told that we can fire it up, and there is no short anymore, so maybe the short has already burned out or whatever. So let's check that, and then let's go into it. Okay, so I've connected it to the power supply, and it is drawing 6 milliamps as standby current, which looks normal. So let's try what is going on. So we see it can be switched on, and obviously it can be operated, so that all is obviously okay. So that means short is maybe gone, whatever. Let's look inside and let's see what we can find. And all happened during FM transmission, so do not really know how much power, but anyways, so believe me, it is smelling like hell. And if we look here to our final, so that is at least our 2 meter and 70 centimeter final stage, and you really can see that it has burned. And we see as well it is a very one of the last revisions which has come out from Yaesu, because we have here already our MOSFET power amplifier, so the RD70V what is it, F, or I don't know, I can't read it really. Anyway, so that is the MOSFET final, and well, let me see. So you really can see here the burning marks. So we definitely can be sure that our final transistor is broken, toasted, and well, so the only thing, or the only question left is there another component which died together with the final? But well, I guess first of all, let's take the final out, and let's see what we have. Let's do one step in between before we take it apart, because I just want to know if still our DC is present at our transistor. I mean, here we have our input, and yeah, I should finally connect the power supply to it. Okay, better with power supply. So we have here, of course, our input voltage, which we have, and normally we should have at our amplifiers, we should have the voltage as well, but it is not there, which is not really normal. So I really hope that everything is still fine with it. Okay, not so good. Okay, so that must be the corrosion here. So it depends where I put my probe down, and you see it is there. So that means that most likely nothing else has burnt off, so a trace or whatever. So looks good. Now let's go and let's take out here our final. So first we try to clean it here a little bit, because all the corrosion is not very easy for the soldering process. So I try to get off some of the corrosion here. Yeah, simply to make it easier, and to make it easier in the second step is to put some new fresh solder to it, to get a mix of the leaded and the no leaded solder, to reduce the melting temperature. So that is what it is for. Therefore, first we put some flux to it, so that is what we all already know. And we have to be a little bit careful, because we have capacitors here on both sides of our MOSFET, and of course we want to rescue them to use them again. Alright, so let's see what we can do. I can really feel the ground plane we have here, so that is definitely enormous. Anyway, we need some fresh solder here, and yeah, we will get it done. You see how much it is working here to get it on temperature. So that is definitely no wonder. But doing it really helps to get the old one simply out. And next step is I try to suck as much as possible off before we really go down and take the transistor off. So that is definitely helpful. That may also help to get here our capacitors off, so that our high-graded capacitors, which we have here on the output, and therefore that is definitely very, very helpful to first get some of the old solder away. And now we try to rescue our capacitors. Okay. There is the first one. And of course, we need to get the second one, and then the smaller one as well. Okay, here's the second one. Very nice. And then we take the smaller ones as well. Need to get my soldering iron under temperature. Okay, should be there in a moment. Let's see. It is fighting. Oh yeah. so that is too small. Let's take the Weller, which has a larger or bigger tip, which is helpful here with all the ground plane we have. Okay, and it's the second one. And yeah, we have it. Have to check if they are fine. So sometimes they break. So that is what we definitely need to check, of course. Okay, and the next step is with this knife blade, I try to lift up the leads to get finally our transistor out, but I do it off camera because that is always a little bit tricky, but in an earlier video I have shown the process already. And this construction here is even a little bit more tricky as we have it normally. So we have here an extra, as you can see, metal to have something for the solder pads, because the original MOSFET is built in a different way than the transistors which has been used before. So normally, and the older revision used a normal NPN bipolar transistor and not the MOSFET, and therefore the pads are different. So you see here our original MOSFET is, as you can see, only with the both leads here, and then it is normally screwed down here to the heatsink, and the construction they have done here is a little bit different to what we normally know, and therefore, yeah, it is extra tricky. So be careful when you try to do this job, especially if you have the latest revision with the MOSFET inside. Okay, our board is clean, but I'm not 100% certain if here underneath has burnt something as well. And well, the only way to find it out is to take the board out and look underneath just in case, because yeah, if I put in a new transistor and something is burnt underneath as well, the new one might blow as well. So, you know, I think it is definitely a good idea to double check. Oh wow, I think that was really a good step to look underneath. Have a look. So, what a mess. What a mess do we have here. Unbelievable. So I do not have a clue what really has happened. Well, anyways, we need to clean it up. Okay, so let's try to understand what really has happened here. I mean, it looks like that for some reason we got a short between plus 13.7, so the supply voltage for our MOSFET, and ground, and so this trace here is obviously the supply voltage 13.7, and all around is ground. So that is switched to beeper. So we see we have ground everywhere, If we go down here, for instance, everything is ground, and that here should be ground as well, but yeah, it is heavily destroyed, and I do not really know what happened first. First the problem with the transistor, or did something happening here? So here is no capacitor foreseen, and so you see that this pad here is completely clean, and obviously look here, so that is completely loose, what we have here. And yeah, definitely I'm not sure what happened here. So that must be finally our transistor which made the problems. So, and I do not really see it. So, okay, let's try to clean it, and maybe when we have cleaned it, that then we see it here a little bit better, because it is too much carbonized here that it is possible to really see clear. Well, by the look of it, it seems that everything happens because this cap here might short it out. So not 100% sure, because when we go and test here, no, that is not a short, so you can hear it, but connecting my probes here to the capacitor does not really show a short, or it is already burned out. So that is of course possible. Then we should be knowing what has happened when we take the cap out and test it. Maybe that we then see what it is. I mean, of course, it could have burned out, so we don't know. So I believe we really have to take it out to be more, or get more informations about the component itself. Yeah, it's out, and definitely it is toasted. So it has no short, but it is open. Anyways, we cannot use it any longer, so we need to find new capacitors. One problem is that this company, this ship company who produces this special HF capacitors for over 500 volt and so forth, it's a kind of film capacitor. So this company is, as far as I know, not any longer in the market. So we need to find something which can be used as well for those applications. So you see, it is always again and again a challenge to get the right components for repairs. So yeah, let's see what we can do here. Okay, but really my biggest concern here is that I mean, you see these holes here, and that is a through connection, and when I flip it over, it is of course exactly the area here where we have our problems. So, and we have seen it that it is underneath completely destroyed and carbonized, and that means that of course our throughs, which we have normally here present are totally gone. And that means that it will not work until we have here a good through connection. And well, yeah, that is something what I really do not like. I can tell you what in cases like this, what Yaesu would do. So they would offer an entire new PA board, which is approximately, I don't know, 700, 800 bucks. And that is what they would do. And well, to repair it in an area like this is really something critical, because you know, we really have high voltages here, and that is really no fun to deal with it. We really have to be very careful, because otherwise it can easily burn off again after we have done the job. So really, to be honest, I am not really happy with this job here. I don't know. I think I have to talk to the owner. But we would not be TRX Lab if we not even try to fix it somehow. And so I've started to put in some bridge wires, which we really need to get to the individual through hole here to get a solid connection. So now let me do that first, and then we go ahead. Okay, as you can see, I've repaired here the board as much as possible, and I have a new high voltage and high Q capacitor in. So we are ready here on this side, and now we should do a new transistor in. But first let me check here if or what our tester says, because we should not do anything stupid. Okay. Okay, yeah, so that is definitely toasted. So you know, it died obviously together with our capacitor, which burned off, and the transistor burned off altogether. Most likely first there was a problem with the capacitor, so that is what I believe. So that is a multi-layer capacitor, and sometimes they get a crack and start burning off. So I've seen that quite often, and then suddenly it happens that the transistor then died subsequently. So that is how it goes. Let's see if what we have done here will last for longer. We never can say, because it is always critical to do something like this, especially as high as the frequencies get, as more complicated get those repairs. So that is the reason why you never would get a repair like this from ICOM or Yaesu or whoever would get it into the factory service center. So they never would do something like this. So they always would offer a new board, but as already discussed, that is really expensive, and therefore we try it, but we never can promise that it lasts forever. Okay, so far so good. So the new transistor is in, and you will have seen that it was already critical. So now here underneath the new transistor at this lead we have our wires which we put through the vias to finally get the connection to the other side of the board. So we have here now a kind of hill, and that is the reason why it looks a little bit funny, because I had to place in again here these capacitors, and I upgraded here on the input side the capacitors to high voltage and high Q capacitors, so that is really crucial to do this right with good components. So you see that is done, and due to the fact that it is a little bit problematic with what we have done, it does not look perfect, but we all hope that it will work, and so yeah, let's give it a try. Alright, so we are already prepared for testing, and you may know that it is critical when we have implemented a new final that we really need to take care for the bias current. So the setting I have done here is bias setting, because of course we need to check that first, and I do not want to touch the PTT before we have set everything for testing. And you know, bias get adjusted without any audio, but of course PTT down, and then we should get our bias voltage, which will of course lead to bias current. Okay, so in a short look here into our manual, we find that we should get 1 amp for idle current adjustment, so that is bias current. So therefore we have done all the connections, and now without any audio we should see on our amp meter 1000 milliampere, which is 1 amp. I normally set it a little bit lower, because when it heats up, of course the current increase. So I would set it around 900 milliamps, so that should be for a cold radio. Okay, so you can see here our so we should not have any reflections, and now you see our amp meter, and you see it is 200 milliamps, so that needs to get increased. And you see when I'm talking, so we get more current, which we don't want. So now I stop talking, and you know that we need to get it just around, let me say, 900. Okay, so that looks good. Yeah, pretty nice. So you see it increase while the temperature of our new final is getting up, and I can feel the temperature. It is getting up. It is not hot, but I'm recognizing an increasing temperature. Now I'm switching over to let's say so we get normally 20 watt on UHF where we have set the radio according to our service manual. Now let me go down to 5 watt output power and let's see what we have. Okay, so let's check here our power amplifier, our power meter. And remember, so I have a 10 dB power attenuator in front here of our input. And when you see here 0.3, that means 3 watt. 1 means 10 watt. 30 means 30 watt. So now here the 0.3 watt LED is on, and that means that scale end, lower scale, means 3 watt output power, right? Now I have set the radio to 5 watt, and let's see when I now transmit what we see. I should really set it to FM, because I've done the setting, of course, in I've done the setting at upper sideband SSB, because we didn't need a carrier to set our idle current or bias current. Now I've set it back to FM, and now of course we get the carrier, and let's see. We have approximately 4 watt, which is fine. And now let me crank it up a little bit. Let's see what we have here. And 10 watt, so I'm on 10 watt. And you see 1 means 10, of course. And we are scale end, upper scale, that means 10 watt. Okay, so let's go for full power. And that means we should see on the 3, that is the lower scale. Now it is a little bit about 20 watt output power. So that is really nice, because now we know our radio is back working. So it died on 70 centimeter, and now with our repair it obviously is successful. But of course I want to check VHF, so that means 2 meter as well. And 2 meter is maximum power is 50 watt. So now I've set it to 20 watt on 2 meter, and let's see what we see there. Let's have a look. 20 watt, so that is pretty good. And now let's go, let's say, to approximately 30 watt, and you see, yes, 30 watt is given. And now let's go 40 watt, and now we should go over to the upper scale, and 40 watt, perfect. And let's see if we can get the 50 watt, which is the limit for VHF 2 meter. Let's see, 50 watt is set, and yes, 50 watt, perfect. It is really working perfect. So everything is really, really nice. Okay, now I have put it down a little bit, so not too much power, because now I want to see if our modulation is working, and you can see it right here. And what you can see here is the frequency. So I'm still on 2 meter. So now I'm pressing 149 you can see that. So that is a free band frequency, and we are approximately at 10 watts, so that is fine. And now let's see. And you see that we have a deviation of approximately 4.8 kilohertz. So that means it is working fine. Okay, and here a short RX test, and you see radio is running really great. So we have a good receive, as you can see, a SINAT of 32, so that is definitely perfect for our receiver. So we are transmitting into the radio with minus 111 dBm, which is absolutely good, no question. And here you can see the 12 dB point for SINAT, which is at minus 100, approximately minus 122, which is fine, absolutely okay. And yeah, on 70 centimeter as well, let's double check here. Deviation approximately 5 kilohertz. So you really can see that it is really working perfect. So I would call this repair definitely a success. What can I say else? So we have done here our idle current setting as we have found it in the service manual. So everything has been done. New transistor together with our repair, which we all know is not what the factory service ever would do, but I believe if it works and it looks good, everything, we can give it a try in the field. So yeah, it looks all very promising, and therefore I believe it is good. Okay, so of course I have to do some additional final work. So here our bridge have to get back in where we have taken our idle current test from. So that needs to get back. So that is basically a little bridge. It is a wire which get soldered in, so nothing special. And then I put it back all as it should. And well, that's it. I again would call it successful. Hope you enjoyed it and you was able to learn something. And so we are definitely at the end of the video. Thank you for watching. Catch you next time. Bye.